Hello everyone. This week we're going to be going over 4 sections as opposed to our normal 2, but each one of our sections are a little bit on the shorter side. So with our first video here, we're going to combine sections 1.4 and 1.5, and then we'll have a separate video for each part for section 1.6 and section 1.7. So going forward here with sections 1.4 and 1.5 combined, we give them 3 objectives. So our first objective is that we want to add real numbers. Our second objective being that we're going to use the definition of subtraction. And then for our third objective, we want to use the order of operations when adding or subtracting real numbers. So starting with our first objective here, adding real numbers. When adding real numbers with the same sign, either both are all positive or both are all negative, we can add their absolute values and carry over the sign. So if we're adding positive values together, whether that be 2 values, 3 values, so forth, we want to take our absolute values and then we carry over whatever sign both of our numbers had. If they were both positive, we would carry over the positive sign and our final answer would be positive. If they were both negative, we would still add together our absolute values, but since our initial numbers were both negative, we would then just carry over that negative number. So for example here, we see we have a -2 plus a -4. So we add our absolute values together. Our absolute values of -2 and -4 are going to be 2 and 4 respectively. So then when we add our 2 and 4 together, we get 6. But since our original numbers were negative, we have -6 would be our final answer there. And then with our positive numbers, if we had +2 plus +4, we could take the absolute value of +2 and +4, which are going to be 2 and 4 respectively, and when we add them together, we get +6. So when adding numbers with different signs, we find that they're absolute values, and we subtract the lesser absolute value from the greater. And the sum has the same sign as the greater absolute value. So a little bit confusing here. So when we add numbers with their different signs, we find the absolute values of both numbers, and whichever one has the lower absolute value, so after you've taken your absolute value, whichever one has the lowest absolute value, or the lowest number, we subtract that from the larger number. And then the sum has the same sign as the greater absolute value. Once again, the greater absolute value, not the greater number. Once you take your absolute values, that's when you do all of these operations. So for example, if we had -2 plus 4, this absolute value of -2 is going to be 2, and the absolute value of +4 is going to be 4. Since 4 is greater than 2, we subtract the 2 from the 4. So then we have 4 minus 2 is equal to 2. And so we have +2 because also our sum has the same sign as our greater absolute value. And our greater absolute value in this case was +4. So our final answer is +2. Then if we switch our signs, so now we have +2 plus -4, the absolute value of 2 is 2, and the absolute value of -4 is 4. Since we see that our absolute values are still 2 and 4, 4 is still greater than 2, so we're still going to subtract 2 from 4. But now our greater absolute value, which was +4, the original number has a negative sign. It was a -4. So our final answer is -2. So there's that little bit of a difference there. So for objective 2, using the definition of subtraction, we want to recall that the answer to a subtraction problem is a difference. So where we say sum for adding numbers together, the answer to subtraction problems is the difference. In the subtraction x minus y, x is called the minuend and y is called the subtrahend. So these are just ways that we label the numbers that we are subtracting in order to get a difference. And we just call them these certain names so that when we do have our definition of subtraction, we know which one we're going to end up talking about, because remember that subtraction depends on order. The order in subtraction matters. So with our definition of subtraction here, we say that for any real number x and y, where x minus y can be defined as x plus negative y. To subtract y from x, we add the additive inverse or the opposite of y to x. In words, we change the subtrahend, so the second number, the number that you are subtracting from the first, to its opposite, and we add. So we're changing our subtraction now from a subtraction problem to an addition problem, just with addition with maybe a different sign. Or we're changing it so that we're having its additive inverse instead of subtraction. So for example, if we were to take 4 minus 9, this is the same thing as saying 4 plus negative 9. And when we can add these numbers together, we use the same format that we just went over on adding numbers with different signs, and this gives us negative 5. So when subtracting signed numbers, step 1, we want to change the subtraction symbol to an addition symbol and change the sign of the subtrahend. And then we just add the signed numbers. So this is the same thing as we kind of just discussed with our definition of subtraction. This is just telling you the 2 steps it takes. So whenever we see subtraction, we can always rewrite it as addition with the additive inverse of the second term. So let's do an example. We want to find the difference of our numbers here. So our 3 divided by 8 minus negative 1/4. So just to help us label, our 3 divided by 8 is our minuend, and our negative 1/4 is our subtrahend. Subtrahend, yes. Couldn't remember if there was an H in there. All right, so we have our minuend and our subtrahend. And using our definition of subtraction, we want to add the additive inverse of our subtrahend instead of subtracting it. So we can rewrite our question here. We keep our minuend or our first term the same as 3 divided by 8. And now we are adding our additive inverse of the subtrahend, or we're adding the additive inverse of negative 1/4. So remember, our additive inverse or opposite is the same number with the opposite sign. So negative 1/4 is just going to become positive. We can put a little positive sign, 1/4. And put those in parentheses to signify that this was our additive inverse. So now we just have an addition problem. And now we're just adding our fractions. If we want to add our fractions with 3/8 plus 1/4, we need to find a common denominator in order to add them. We see that our denominators here are 4 and 8, which 8 can be separated into 4 times 2. So we just want to use our property of 1 on our second term here in order to get our common denominator. So we can say 3 divided by 8 plus 1 divided by 4 times 2 over 2. Let's go to our next line here. So we still have 3 over 8, which is our first term. And now we have 1 times 2 in our numerator and 4 times 2 in our denominator, which we know that 4 times 2 is 8, and 1 times 2 is just going to be 2. And now we have our common denominator. Since we have our common denominator, we can add our numerators together to get 3 plus 2, all divided by 8, which is 5 divided by 8. So that would be our answer for when we have 3 divided by 8 minus a negative 1/4. We end up with a positive 5/8. All right, so we can also use the minus or the negative symbol for 3 separate purposes. So for 1, it can represent subtraction. We recognize this as saying minus, so as saying 9 minus 5 is equal to 4. So it represents subtraction in this case. It can also represent negative numbers. So if we put this sign in front of a number, it signifies that this number is negative. So negative 10, negative 2, negative 3. And the third one, it can represent the additive inverse or the opposite of a number. As in, the additive inverse or opposite of 8 is negative 8. So we may see that more than one of our minus signs or negative signs are in the same expression, such as negative 6 minus negative 9, where negative 9 is subtracted from negative 6. The meaning of the symbol depends on its position in the algebraic expression. So it is important to kind of think about these numbers. When we see them written out and they're all kind of in one straight line, it can be a little bit more confusing, but if we were to write them ourselves, we can say something along the lines of negative 6, and then we have minus and negative 9. So maybe we add that negative symbol a little bit higher up on our numbers to kind of indicate that these numbers are negative. Maybe we make them a little smaller as well. So you can see them written in different ways, but it is important to know which one refers to which. So whenever we see this negative sign right in front of another number, and then maybe another one, so in the case of right here, we have minus negative 9, this is telling us that we're subtracting a negative number. And since there's no number here in front of 6, we know that this is negative 6 and it's not minus 6. So just a quick overview of the different purposes of that symbol. Then lastly, objective 3, we want to use order of operations when adding or subtracting real numbers. So as a reminder, our order of operations tells us that if grouping symbols are present, we want to work within them innermost first and above and below fraction bars separately in the following order. Step 1, we apply all of our exponents. Step 2, we do any multiplications or divisions in order from left to right. And step 3, we want to do any additions or subtractions in order from left to right again. If no grouping symbols are present, then we just start with step 1. So just a quick overview of our order of operations, which we've gone over quite a few times now, but just to help us go forward in our problems. So now we're just putting together everything we've gone over so far in objectives 1 and 2 to put them into practice with objective 3 in combination with our order of operations. So for a second example here, we want to perform each operation. So for part A, we have 2 minus, and now we have brackets of 10 minus 6. So using our order of operations, we always want to do whatever is in our grouping symbols first. So we're going to calculate 10 minus 6 first. So we have 2 minus our brackets. And since we said that we can change any subtraction problem into addition with additive inverse, we can do that here as well. We can say this is the same as saying 10 plus negative 6. So if we add 10 and negative 6 together, we're going to get 2 minus 4. So now since we have 2 minus 4, once again, we have a subtraction problem. So we can change this again into adding our additive inverse. So since we have our number 4, our additive inverse is going to be negative 4. So we're going to get 2 plus negative 4. And when we add 2 and negative 4 together, we can, remember, take our absolute values. So the absolute value of 2 is 2. The absolute value of negative 4 is 4. Since 4 is greater than 2, we subtract 2 from 4, meaning 4 minus 2 is equal to 2. But then, since we remember that our answer or our sum takes the sign of our highest absolute value, which in this case was 4. It takes the original sign of what we had that absolute value of. So since that value was -4, our sign or our final sign is going to be -2. So 2 plus -4 is -2. All right, then have our other problem here. So we have the absolute value of 4 minus 7 plus 2 times the absolute value of 11 minus 9. So we want to do the same thing as we did before. But now we have two separate grouping symbols. We have our 4 minus 7 and we have our 11 minus 9. We also have our 2 multiplied by our 11 minus 9, but remember we want to do everything in our grouping symbols first. So if we want to do grouping symbols first, we can start with 4 minus 7 and we work in order from left to right. So with 4 minus 7, or our absolute value of 4 minus 7, we can change 4 minus 7 into 4 plus -7. So we have 4 plus -7. Then our second grouping symbols, we have 2 times 11 minus 9. And we can rewrite this as 11 plus -9. And let's put this -7 in parentheses here. -7. There we go. All right. So we've rewritten our problem to now be the absolute value of 4 plus -7 plus 2 times 11 plus -9, or the absolute value. So now we want to do the same thing as we had before. So this is our first grouping symbol, so let's just label this 1. And this is our second grouping symbol, so we'll label this 2. So for 1, we have the absolute value of 4 is going to be 4. And the absolute value of -7 is 7. We see that 7 is greater than 4, so we subtract 4 from 7 and get 7 minus 4 is equal to 3. But remember, our greater absolute value in this case was 7, which was originally a -7. So then we carry the negative symbol from -7 to get -3. So our value here is -3, and remember, inside of our absolute value. So let's do our second grouping symbol here. So with our second grouping symbol, well, let's kind of move on here from our first part. With our second grouping symbol, we have 11 plus -9. So we want to do the same things. Our absolute value of 11 is going to be 11. Our absolute value of -9 is going to be 9. And then we go through the same process. We see 11 is greater than 9. So we subtract 9 from 11. And we're going to get 11 minus 9, which is 2. Then, okay. So we have 2 now. And then remember, we want to carry the symbol from the greater absolute value, which in this case was 11, and our original version was +11. So we're carrying the positive symbol from 11 to 2. So our final answer here is 2 inside of our absolute value bars. So let's plug these values back in. So originally, remember that we had absolute value of 4 plus -7. So continuing on, which we figured out was -3. So we have the absolute value of -3 plus 2 times the absolute value of 11 plus -9, which we found was +2. So 2 times the absolute value of +2. So now we just want to take these absolute values. The absolute value of -3, remember since -3 is a negative number, we take the additive inverse, and that is the absolute value. So our absolute value of -3 is going to be 3, and our absolute value of +2 is just going to be 2. So now we have 3 plus 2 times 2. So now we have a very simple equation with our order of operations. Remember, we always want to do multiplication first. So we're going to multiply 2 by 2, and we get 3 plus 4. And now we have our final answer here, or our final equation to solve, which is 3 plus 4, which is going to be 7. So our final answer here from our original equation is 7. So all right, that concludes our combined sections of section 1.4 and section 1.5. So moving on, next time we'll be doing section 1.6.